Hello, my name is Razvan Daniel Ursachi and I will show my fifth hand in procedural programming. This time we had to create a small sort package including the sort functions in C++, and our program should be easy to be used by other users just by including our file and using the functions. I will just show you how is it working for now. So let's run it. uh, the program is asking you for 5 numbers, so let's add 12, 34, 22, 87 and 55. Afterwards, the program is asking you what kind of sort would you like to do, and let's try for example quicksort. So let's press 4, enter, and you can see here the program was sorting the numbers for you, so they are now on the right way from 12 to 87. And let's see how is this actually working. Here is my project in CodeBlocks called sorts, and I have two source file, a main file and a file for my functions, and also a header. The most important files of this project are the C++ file for my function and the header, which you can add it to your own main file if you would like. So my main file is not mandatory. I was just creating it to use the functions I wrote in my functions.c++. So basically in the main, as you have seen, the program is asking you for 5 numbers, and afterwards he is reading 5 numbers, and then the program is asking you for the kind of sort you would like to use, and it is reading the number you chose, and afterwards I created this switch case, and depending on the number you chose for the sort of the sort, um, you can one function will be called. How it will be called? As you can see in this main, I don't have any function written. So what is happening is that I included the header of my functions. So let's see the header of my functions now. The header of my function is just having these declarations of 4 functions, of the bubble sort functions, insertion sort function, selection sort function, and quick sort function, plus another function which I haven't finished, so it will not be used. That's why it is under command for now. Um, this header is calling the C++ file, my functions, where all of my all the sorting function were written. So you can see here the bubble sort function, and it is called by the header here, and afterwards used in the main C++ here. So it is the same operation, the same process for insertion, for the insertion sort function, for the selection sort function, and for the quick sort function. And here is again under comment the binary tree function, which I haven't finished it. The differences between these four sort functions is they are working differently, and they can be more efficient or not. Like for example, bubble sort. What is happening with bubble sort? In bubble sort, I will show you an example. The thing is that here you can see you, the programmer, are programming the computer to compare every two numbers. So you are actually creating some bubbles. So you are comparing 5 to 3 in the beginning, and uh, let's let's refresh it. Let's see from the beginning. Mm, it is not refreshing. Anyway, you are comparing 2 by 2, and if this is smaller than the other one, you are just changing them. So 3 will come in the front, and 5 will go to the end. And in code, you can see here, I was creating this by using a do while loop, and this do while is having a condition by a boolean. And when the condition will became true, so all the numbers will be in order, we will just be out of the loop. Afterwards, inside the loop, another loop was needed, and this was needed because we need to compare all the numbers two by two, so like bubbles. And afterwards, we are comparing the numbers, and if the first number is bigger than the other one, we are changing their order. So the smaller one will come first, and the bigger one will go last. This is about bubble sort. Insertion sort. Okay, so I'm back. Um, the next function is presenting the insertion sort, and what is happening here. Let's see, I'm having another animation for it. Yes. Um, what is happening is that you are starting with the first number here. We will see it now, and the first number will just be compared to the next one, and if it is bigger than the next one, it will change. Then we are comparing the next number, not 6 because it was used before, and we are comparing with the numbers before, and if it is smaller, for example, it will go um, the first one. And for example, 1 will go the first one now, and afterwards 8 will be compared, and it will stay on the same position. um, in code this is done by one for loop and one while loop. What is happening is that you are going through all the numbers, like from the first one to the last one, and afterwards you are changing the position of the number if if it was bigger than the next one, the next number. So we will go to the right order in the finish. Another another sorting solution is selection sort, which is similar to insertion sort, and it is having the same efficiency. Until now, like bubble sort and insertion sort and selection sort, they are not the best solution to use. They are not so efficient, so it will take some time for the compiler uh, to process it. Um, the best one from this pack is quicksort, which is doing in almost half time than the other, so it is more efficient. And that's because we are comparing numbers starting from two sides, and I can show you the quicksort example. Is the thing that you are actually going in the beginning from here and from here, and you have like a cursor, uh, which is the middle of your array, and you are comparing numbers two by two, and when you are in the middle, uh, half of your numbers will be compared, and you will start just from the numbers they were not compared until that operation. And that's it. I couldn't do the binary tree sort solution, and I'm sorry for that. I will try in the future, and I hope that the teacher will help us about it too. So that's it about it. Thank you, and see you next time.